And you should see a little arrow pointing away from the 0 now.
STO.
Above the on button. Okay, store. Now, follow my button pushes here. Press the math button. Then left arrow once. Probability, perb, exactly. And then you see the one that's called rand?
The PRB one.
PRB is 4.
Just left arrow once. Don't worry. Yeah, PRB is probability.
Mine's 4.
Mine's 4. That's over 4.
You have to go right 4 or left 1.
No. No, sir.
Then press enter. Now it should say, I wish I could show you this. It should say 0, arrow, rand.
Right.
Okay, press enter. Boom.
0.
Okay, now, right, it says 0. That's just the TI saying, yes, I stored that into the randomizer. Now everybody do this. Press the math button again. Press the left arrow button again. And then press the enter button. Now, before you press the enter button again, I'm going to read your TI's mind. When you press enter, it is going to say 0.9435 and then some other stuff. Go ahead and press enter.
Correct.
That seems extraordinarily strange. RAND stands for
Random.
random. If your TI is generating a random number, why is it that I could figure out what yours was going to do? As a matter of fact, if you hold your TIs out to everybody else, they all have the exact same number you do, yes? Everybody has the exact same number.
0.94.
That means you didn't store 0 in, Joe. If you got a different number, you didn't store 0 in. And that's good, because we don't want us all to have the exact same number. The problem with randomness, the word random, this goes into probability, the word random means every single number has the exact same chance of showing up over time. We've had this discussion a little bit before when we talked about estimation and other things like that. So if I'm generating a 10-digit decimal, how weird would it be that we all generated 0.9435974025? All of us generated it. It's almost impossible, right? It could happen, but it probably won't happen. So what we're going to do right now is we're going to force it not to happen. And we're all going to do what's called random seeding. The problem with a computer trying to be random is that it can't. A computer cannot be random. How does a computer work? Oh, Micah, go ahead.
Logic.
Program.
And what's a program? A series of what?
Zeros and
Series
ones.
of
A
commands.
series of steps. The zeros and ones are the inputs and the outputs. Yes, yes, yes. But what is being done to the zeros and the ones?
Put down.
Telling it to do a specific thing.
Exactly. These things called algorithms, or little functions, or little codes that tell these inputs of zeros and ones to do something. Well, that's exactly the opposite of randomness. Randomness doesn't want any kind of a code. It wants to just happen. That's why when you grab a die and you throw it, you grab a die and throw it, there's no equation. There's just physics and the rolling of the die. That's almost pure randomness right there. So we have to force this to be more random than it is right now. Here's what I'm going to do. Here's what I think we should all do. Everybody type in your birthday without slashes, without anything, just month, day, year, or day, month, year, or whatever you want to do. And it doesn't matter if you do like 19 blah blah or just the last 2 digits of the year, as long as whatever number you put in, you think is going to be different than everybody around you. So I'm going to put in 62873, which I'm fairly convinced is different than everybody else in this room. Okay? So that's why I picked birthday.
Without any rand or...
You say that again? Just type that first. Don't do anything else. Type those numbers, or not those numbers, type your numbers. Now, press the STO button. Good so far? And then now, go find that rand command again. Math, PRB, rand. So now it should have your birthday, arrow, rand. Now press enter. And when you press enter, it's going to come back with your birthday. Cool so far? Now everybody go back and find just the rand command again. So math, left, enter. Math, left, enter. I'm going to press enter. I got 0.6424. Who else got 0.6424? Good. How many of you guys got 0.1 something? Hey, don't tell me yet, don't tell me yet. I'm going to predict 5, 10. I'm going to predict about, let me see, we have 20 people. I'm going to say 2 of you. How many got 0.1 something? Okay, 4. I was 5. I was off by a bunch there. How many got 0.2 something? Should be about 2. Okay, we got 2. How many 0.3 somethings? 0.3, there's 2. 0.4 somethings, there's 1. 0.5 somethings, there's 1, there's 2, good. 0.6 somethings, that was me included, there's 3 of us. 0.7 somethings, Good, 0. That had to happen somewhere. 0.8 somethings? Okay, one of us. 0.9 somethings. There we go. There's the rest. So what I did was I did a real quick check of the room. How many people were in the room? I guesstimated at 20. It's more like 25. There should be, if there's 25 people in the room, and I break up 0 through 1 by tenths, how many should we have in each one of those ranges, do you think? Roughly 2.5. Roughly 2.5. I was just checking real quick. So we should add. Now, the assumption there is that that is now operating randomly from 0 to 1. Now, we got a bunch of, there were 5s. There were 0.9s, there were 5s, and then there was, I think, 0.1s, there were 5s. We were heavy in certain areas, but then we were light in other areas, yes? There were no 0.7s, I believe. 0.7s, it was 1.6, no, 3.6 or 1.5 and things like that. Everybody press it again. Press it again. Okay? Who's between 0 and 0.1? Between 0 and 0.1. I'm the only one that, oh, no, we got 4 of us, 5 of us, 5 of us. Who's between 0.1 and 0.2? 0.1 and 0.2. Just 1. See that balance right there? There were 5 in the beginning, in between 0 and 0.1, and only 1 between 0.1 and 0.2. That balances off to 3 per. Correct? Heavy on one side, light on the other, but it balances off. 0.2 to 0.3s? 0.2 to 0.3s, still light. Oh, 2, there we go. 0.3 to 0.4? You see what's happening? We're getting different numbers and they're spreading out. 0.4 to 0.5? Yes, good, 3 of us. 0.5 to 0.6? Excellent, a couple of them, 3 of them. 0.6, 0.7? Here's a blank again, very nice, very nice. 0.7, 0.8? 2. 0.8, 0.9? 3 of you, and then the rest of you, 0.9 and up. Remember how 0.9 was heavy last time? Now there were 0 in it. Now there were 0. That's the point. And no pun intended. But the idea is when you check these things like randomness, you have to run many, many trials to begin to see overlying patterns. Or underlying patterns. I said overlying. Underlying patterns. That's what we're going to do right now. Let me get a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 people in the room. Here's what we're going to do.
Sean, you might want to fix this a little bit.
Oh, it's not even recording. It's just getting my voice right now. I'll fix it when we start getting some actual data to look at. Thank you, Linda. Appreciate that. We're going to run some trials. Go ahead and start your columns. Now, I remember we needed a lot of trials to actually get this thing to exhaust itself at some point. So we're going to 10. If we need more, I'll ring the wall, I guess.
So we're going to edit L1.
Yeah, you can if you want to, Ben. If you go put it, we'll do that later, for sure. If you want to put that in L1, that's a great idea.
All right.
I mean, you don't have to at this moment, but because we have to collect data first. Now what I want to do is I want to keep track of the number of people still flipping a number of times until we're done. Now, if you weren't here last time, you don't know what I mean by number of people still flipping. So let me add to this. Until we get, was tails, right?
Yes.
Not that it matters, but let's just define it as tails. Okay. So, at trial 0, there are 28 people flipping. Because nobody's flipped yet. So you're still flipping to trial 1. Then what we're going to do is we're going to keep track of anybody that flips heads on the next trial. Does that make sense?
Why are we doing 28?
Because there's 28 of you in the room.
There's 24.
24! Thank you. Because I counted wrong. Because I remembered wrong. I counted right and remembered wrong. 24. Thank you, Linda.
So that's number of people.
In the room right now, pre-flipped. Nobody's flipped at all yet.
I know, but for the top.
Yes, and believe it, and we're going to use that number across no matter how many times we do this. I think we'll do it like 4 or 5 times. We're going to use 24 as a starting point, assuming nobody leaves between now and the time we finish collecting data. We're going to start with 24 each time, and then we're going to begin flipping. So here's what I want us all to do. We have to make this into a coin. Now there's 2 ways we can do that. One way is a little bit messy. You can just press your enter button again. You generated a new random number, right? You didn't. You must have pushed something in between. If you just keep pressing enter, you should be getting new random numbers each time, yes?
Yes.
So as you push them, you'll notice that sometimes they're above 0.5 and sometimes they're below. Yeah? We could use that as a heads or tails estimate. But there's an easier. Oh, go ahead, Tori.
On the apps, there's a coin toss section.
There is, but not everybody has that app on the 83s and things like that. So what I'm going to do is we're going to use something We're going depending on the version that I have it. So here's an easy fix around that. Here's an easy fix around that. Press the math button. Press the math button. Go over to the PRB menu again. Go down to find the one that's called rand int. Select that one. Now you see rand int left parentheses. Let's put in two numbers. How about 1 and 2? 1, comma, 2.
Wait, how do you do a
Where's the
comma?
comma?
Oh, there it
Above
is.
the
Okay.
Okay? 1, comma, 2. And then close your parentheses off. Now, press enter and see what you get. Keep pressing enter. What are you getting? You're getting 1s and 2s. Are you getting predictable numbers of 1s and 2s? No, they're random. It's randomly generated. It's essentially doing the same thing I just described with the rand command. It's generating 0s to 1s, and it's keeping track of where they fall. If they fall below 0.5, it calls it a 1. If it falls above, it calls it a 2. But this is a little bit easier to see. So let's make a definition right now. Let's define if you get a 1, that's like getting heads. And if you get a 2, that's getting tails. So what we're going to do is we're going to flip until you see a 2. Does that make sense? So as long as you keep seeing 1s, you keep flipping. Does that make sense? Is everybody getting data? Everybody's getting numbers? Yes? It's behaving for everybody? Okay, good. So everybody, begin by pressing the enter button one time. Who's going to still be flipping on the next trial? In other words, who just flipped a 1? Who just flipped a 1 on their first flip? Let me count. I did too. 1. I shouldn't count myself. I'm not in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, those 11 folks flip again. Of those 11, who got a 1 again? Who got a 1 again? 1, 2, 3, 4. Okay, thank you. Those 4 flip again. Of you 4, how many got 1 again? 2. Flip again, please. Of you 2, how many got a 1 again? We're done. Zeroed out. Okay, zeroed out. Perfect. Now we all start again. Now we're done. We flipped until everybody got tails. So we're gonna keep. This is just like we did last time, except the coin bag is missing in my office somewhere. Cool. Press enter. Okay. Who just flipped the 1? Who flipped the 1? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of you. You 9, flip again. I can turn the camera off now. We can record all this. You 9.